Yeah, hi everyone. I'm really excited to be here. I've got a couple slides to run through, and then I figure we could maybe spend some time doing some live coding today. I'm always a big fan of doing code live, but that does mean that things might break. So hopefully it'll be like a good roller coaster where it's all positive rather than having a scary bumpy bit as well. So let's talk about software containers. I guess I should probably tell you who I am and why I'm qualified to talk about software containers. I'm Shy. I'm a senior developer advocate at Docker. I've been here since January, and so I'm still in my learning phase of learning everything about Docker. And I'm really excited to get to teach you all everything I've been picking up. I used to be really into front end stuff. My last gig, I was doing content management APIs, and so I was building a lot of Jamstack stuff and doing stuff with Netlify as well. And so coming to Docker has been really fun for me because it's been a totally new skill set and a totally new set of things that I've been learning and I've been getting to use. So throw some emojis in the chat if you've had this problem. And I know we've got a little bit of a delay with the stream and the chat, so I won't be able to react to your emojis live, but hopefully everyone else can. But yeah, raise your hand or give me a concerned emoji if you've had any of the problems that I'm talking about in the next couple seconds. So first off, you've built something and it just doesn't work in the cloud like it does on your local machine. Maybe you have a different operating system. Maybe you're physically working with like real servers instead of cloud servers, and you have to go install operating systems or upgrade the machines or make sure you're using the same version management. And it's a whole thing to keep all of this stuff in sync and keep all your dependencies working and configured and um, it can be a pain. Um, and that's not even accounting if you want to change clouds at some point, or counting for the fact that maybe, you're having version updates on packages you use or operating systems that you use. This is a bummer of a problem, and there's a lot of complexity and things you got to keep in mind to keep all of this stuff working and in sync and up to date. Um, and yeah, so I want to talk about how we can solve those problems. But before we go in there, I want to take a brief tangent and talk to you about shipping. Um, and I love this GIFs. I have a lot of model train GIFs just as a tangent, and they're the best. I love any excuse to show off model train GIFs. So back in the olden days, before color TV was invented, when they were using wind in shipping, for the boats and stuff. Back when they did packaging, there was no consistency in like how goods or services were done. Barrels of radioactive waste, bags of coffee, barrels of rum, different sized boxes, and it was a whole disaster to make sure everything fit consistently on boats. And you had all sorts of different ways of transporting things, and they all have different requirements of like how you size things or how you made things. And so it was a whole hassle to get goods and services around the world. Um, Modern days, so we have color television now. Modern times, containers have been standardized as kind of a consistent way to do shipping around the globe. We have this standard container, and it's the format that's used by about 90% of cargo across the world. So you're able to optimize these transit devices around this format. And regardless of if you're using a train or a boat or storing it in a port, or using a truck, you have a general sense that this container format will just work, and you don't necessarily have to worry about it being accepted from wherever you're sending it off to wherever it's going. You just open it up, you fill it with what you need, and then it goes. So it's really useful. And you might be thinking, Shy, that was an excellent tangent, but how is this relevant to this talk about software containers? And Docker is kind of set up in a similar way. So rather than taking all of these different things, your different operating systems and your different codes, we take all of this stuff and we put it into a container. And so we make those containers easy to deploy and push out to different places. They're reusable. So if your container is using Ubuntu and then Flask and installing sorts of dependencies, it'll reuse things that are already there. So if those dependencies are installed in a lower section of the container, it'll be able to take advantage of them, and you'll be able to know that things in your container will just work. This thing is going to be shipped with everything that it needs to run. How it runs on your personal machine is going to be consistent to how it runs on the cloud. If you work in an engineering team where some people are using Windows, some people are using Linux, some people are using Macs, it can be a whole thing to do deployment across operating systems, and using containers just kind of gets rid of that problem for you. You don't have to necessarily worry about it. So software containers are here to save the day. They let you package up all the code and the dependencies. As well. And I think I already covered this. So I got a little image of kind of how they look, and they run consistently. And we have a bunch of pre-made stuff up on DockerHub. So things like base images, programming languages, data stores. So you don't necessarily need to install MySQL on your machine or build a MySQL container on your machine. You can just go deploy the MySQL container off of DockerHub, and those are maintained generally by either Docker or the folks building things themselves. I know the Node.js container is being maintained by the folks doing Node.js development. So you can be pretty confident that as you pull it, it'll stay up to date and it'll keep working. And so Docker Hub is a nice way to keep track of that. So I think that's enough PowerPoint for me for now, and we can go ahead and switch into some live coding. So let me go ahead and exit out of here as well. And let's get started. So I want to show off one of my projects that I built. I'm a big fan of tracking like big data sets, and not to be too on COVID today, but one of the things that I built was these e-ink screens, and I have them right here in front of me. They're Adafruit e-ink screens. They're called mag tags. They use this ESP32 microcontroller. So it's a microcontroller that connects to the Wi-Fi, and can then render things out on the e-ink screen. They're like $30 on the Adafruit website. I love these things. I think they're great. I have a lot of them in my apartment. But one of the things I'm using them for is to keep a general sense of like, how vaccinated is the world? Because it's just something I'm curious about. So I built a little Flask app that I deploy with Docker onto a Raspberry Pi. So one of the problems with these e-ink screens is that they only have like 2 MB of SIRAM on them, so they don't have the a ton of capacity on them. And the data set that I'm using is being provided by this organization called Our World in Data, and they're great. They do a lot of compiling. They put things together. And they like consolidate all sorts of different data sets from across the globe. So it's a global data set. Right now, data is being put out by all sorts of different entities across the planet. So in the US, it's the CDC. In the UK, it's the NHS. There's a bunch of NGOs that are collecting this data and keeping on top of it. And so our world in data just kind of takes that out and they compile it all together, and make it available in an easy to read CSV for us. Now, one of the problems I have with this CSV, besides how how great it is that it's a huge file. It's a 32 MB file, which again might not seem huge to you, but since I'm doing a bunch of IoT stuff, I don't have 32 MB to spare. I can't bring this file into memory on these mag tags. It's just not going to work. They're just not going to be able to handle it. And even if they could, traversing a 32 MB CSV is going to take forever for my Raspberry Pi. So instead of using a CSV, or instead of directly connecting to it from my mag tag, I have a web server that I've spun up using Flask, and I think we can go take a look at some of that code right here. So this is a fairly simple Flask app, and I went ahead and um, I can run this on my local machine pretty easily. It runs with just kind of a uh, Flask run. Oop, run. Yeah, I can get it going on port 5000 fairly easily. And I'm running this on my MacBook. So the API is online. So let me go ahead and make this a little bigger. Yeah. So the API is online, and I can go and hit specific endpoints. Like if I want to hit the USA data set or something like that, I can pull that. This is a fairly basic Flask app. It's fairly simple. It doesn't do anything too crazy. But I'm gonna go ahead and I'm gonna package this up, and I'm gonna make it containerized. And so I can do that fairly simply. So all I need to do to get started is to build a Docker file. So I'm going to create a Docker file here in this repo. So save it as Docker file. And one of the nice things for folks that are still learning Docker or are new to this kind of stuff is we've got a bunch of documentation on how to get things done. So, we've got language guides, and I always really like to use this thing called Awesome Compose. It's a repo that we maintain that has a bunch of templates of all sorts of different setups that you can use to get going. So in this instance, I'm just doing with Flask. But like if I wanted to do like an Nginx node Redis implementation, this is already set up. It's a blank template and I could download it and I could get started. So here I can click into Flask. Um, I can click into the app and I can look at this Docker file as well. And it's got kind of a general outline of what I need to get started. So first off, my first decision with this Docker file is going to be what do I want the image to be? So I'm not going to build this from scratch. I'm going to build on top of something that already exists. Now, what I want to use is I'm going to use something Python-y. So here we've got the Python official image. It's maintained by the Docker community, so it gets updated fairly frequently. So I'm gonna get started by using Python. And with this project, I believe I'm running it on, I can't see my virtual, yeah. So I'm running it on 310. So we can go ahead and we can pull a 310 image. And we've got a bunch of different options here. So we've got 310 bullseye, we've got 310 slim. We have a different level of like granularity with how much we want to stick to things. So if I want to stick to 310.4, I can do that. If I'm fine with just any 310 version, I can do that. And if I'm fine um, with just a generic 3 release, I can do that too, and I can pick what level of granularity I want. So I'm going to use this 310 slim image. um, I like slim images because they're a lot smaller than the general Python image. So by using this, I'm going to be cutting down from about a gigabyte when I make this image, when I build my image, down to about 200 megs, which is going to be really useful for me to save space, and especially since I'm planning on deploying this application on a Raspberry Pi, um, it'll help keep things manageable for me. So to get started, we can do this. I'm going to do from, and let me pull up VS Code from. So my base image, Python, yeah, if I can spell it. Hardest thing about computer science and being a programmer is spelling by far. 3-slim, right? Um, and then I'm going to want to go ahead and let the container know, hey, this is the port that whatever's running inside of the container is going to need to expose out to the world. So I can expose port 5,000. And then I'm going to set the work directory. So this is going to be where all of the code that I run or copy over into this container is going to sit. So I can do a work dir, and I'm going to call it app. Um, Now I need to think about my dependencies here. So this container just has a generic Python install. It doesn't have Flask installed onto it. It doesn't have any of that stuff. So just like I would do in a virtual environment, I can copy over copying over the requirements file is a thing that I'll do here, and I'll copy it into this app folder. But I can also go ahead and do an install. So I can run pip and I can install my requirements file. Um, so this will go ahead and take care of installing all of my dependencies for me. Next, I'm going to go ahead and copy all of my source code into the container. So I can do that with a copy dot and then push it over into this app directory. And one of the things I don't want to do is I don't want to bring along my PyCache. I don't want to bring along um, any of my um, any of the kind of artifacts that get generated when you're writing code. So I can use this Docker ignore file and I can add a bunch of stuff in it to um, just be like, hey, Docker file, don't copy these things into the container when you build it. I want you to ignore these things or skip these things. Kind of similar to how a git ignore works. So I can copy all my code over, and then I can actually run it. So I'm going to run it as entry point, and this is going to be in JSON syntax. So I'm going to have to use double quotes, and I'm going to do Python 3. And then I'm going to set a command, so CMD, um, and then I'm going to do app.py. So that's the name of my app for this project right here. So the reason I'm doing this is 2 different layers, is entry point and command. We could actually do either of them. We could do just an entry point or just a command. The nice thing about entry point is that takes anything you type in after you run that container and will run it for you. So if I need to do some debugging, I can just use this um, entry point and maybe run specific files or specific functions. And if you leave that empty, it'll default to putting whatever's in the command section after the entry point. So when I run this, if I just do a Docker run this container, it'll run Python 3 app and it'll run in this folder. So I'm going to go ahead and save this. And I'm going to go ahead and build it. So let me build this for my local machine. And I can do that with a Docker build command. And I always like to do, take a look at and let me actually move over to my terminal because it's a little easier to read and bump the font up. So cool. So here we've got my terminal. And we can do a Docker, we can check where we are. So we're in the app directory. We've got this Docker file. It's all saved. And we can go ahead and we can build this. So I can do a Docker build, and I can name it. Like I'm going to name it just CFE OWID for this workshop that we're running. And then I'm going to tell it where I want it to build. So I'm going to give it a path, which is going to be in this directory with all my code. Now this is going to go ahead and build. I have a bunch of this cached because I've run this script on my machine, so it's going to be a lot faster. It doesn't necessarily need to go out there and download the first version of Python because I already have Python on my machine, so it's able to go pretty quickly. So there, it's built our image, and we can go ahead and we can run this. We can do a Docker run. Um, command, and we can do it in the terminal, or we can do it in Docker Desktop. And I think I'm going to do this in Docker Desktop because it's a little more visual. I prefer using the command line, but I think Docker Desktop is really great for being able to share things. So I can just hit this play function. Oop, and oh, did that let me configure my port? I don't think it did. Oh, this is a different project. Sorry, that's why that's. So here I can go to my CF. Yeah, that's funny. So I can hit run on this image that I've created, and we can see it's only 139 megabytes, which is pretty reasonable, especially since I'm going to run this on a Raspberry Pi in a little bit. And I can go in and I can name it. So CFE dev. I can set a port. So I'm going to set port 5000. So what I'm doing here is I've exposed port 5000 from the container, and that's because that's what Um, Flask is running. And I can go ahead and map the port from my local machine, my local map of 5000 to map to the port inside the container. So when I hit localhost 5000 on my local machine, it'll go ahead and map to the container port of 5000. And let me just make sure I killed the Flask server. Yep, I killed it. So we won't have a conflict. So I can go ahead and hit run. And Docker Desktop will go ahead and spin this up for me. And then I can go ahead and click open in browser. And with any luck, oh, it opened on the wrong screen. So let me bring this over to the other screen. We've got localhost 5000 and it's running just fine on my local MacBook. Now, I want to get this running on my Raspberry Pi. So I turned my MacBook off at the end of the day. It's a great machine, but it is a bit power intensive, whereas a Raspberry Pi is a lot less power intensive. So I feel totally fine just letting this service live on the Raspberry Pi in my personal network and just running indefinitely. So my MagTag, whenever it decides to refresh, which I have it programmed actually to go at 8 p.m. every day, or whenever I hit the button manually, will refresh and it'll hit that Raspberry Pi server. And so I don't want to leave the MacBook on. Usually at 8 p.m. I'm playing video games or I'm doing something else like in the gym, and so the MacBook is generally off at that point. So I want to run this Flash server on my Raspberry Pi. Now the Raspberry Pi architecture is a little different than the one on my MacBook. So if I move this container directly over to my Raspberry Pi, it's not going to work. What I can do though is I can go ahead and actually make a build of this container specifically for my Raspberry Pi. So what I'm going to do is I'm going to do a Docker build, and I'm going to specify the platform, and then I'm going to go ahead and type Linux ARM E7 because that's what the Raspberry Pi um, Model B that I'm using is gonna need. I can set the tag, and I'm gonna name it Shy Ruparel, and then Flask OID parser, and I'm going to give it a tag of ARM v7. Now I'm naming it this way because I'm going to push this image up to DockerHub, and then I'll be able to pull the image from my Raspberry Pi. So I'm going to go ahead and build this image. And again, it should be fairly fast because I have it cached on my machine. So I think it should be pretty quick. Oh, it looks like maybe I deleted the cache. Oh, here we go. It is going pretty quickly. So I'm building it for this version for my Raspberry Pi. So it'll just take a second. Um, well, so we can chill out here while this is going, and maybe I can pull up DockerHub as well, and go ahead and take a look at the version I have already up there because I already pushed a version as well. So we can do is Docker Docs, so Docker Hub, and so I already have a version up here that I pushed about 20 days ago. So let me go ahead and just push this new version once it's finished. But one of the things I can do now that it's up on Docker Hub is actually I can take a look at some of the vulnerabilities that are in here. So I pushed the generic Mac build up as well. And we can see that we've got a bunch of vulnerabilities. And most of these actually just come from the base Flask or the base Python image. And so it would be up to the folks who manage the Python image to resolve them. But some of them might be things that I've done by adding dependencies or packages. And it's really easy to turn this on. All you have to do is head over to the settings and enable vulnerability scanning. And then Docker, with using Sneak, will be able to tell you, hey, these are some issues that you have. You might need to resolve them as well. So let's go ahead and see. It looks like it's done. I can head over to Docker Desktop. I can hit that image and I can go ahead and push this ARM v7 build. So I can click and push it to hub. Um, cool. And so while that's going, let's go ahead and shift over to my Raspberry Pi. So I went ahead and SSH'd into it earlier, and I already actually have this container running. So let me go ahead and stop it. So Docker stop, and then I can give it the container ID. And I can turn it off. So this will take a second. So with the stop command, it takes 10 seconds to try and stop things gracefully. And then if it can't do it gracefully in 10 seconds, it'll just kill the process. So there we go. And let me make sure I haven't lost the question. Um, yep. So here we go. And let me bump the font on this. So we've stopped it. Now, when I go ahead and reset this mag tag, when it connects to my local network, it's just going to error out because there's nothing on that server. So let's go ahead and run this process on the MacBook. So to start, we can do a Docker dash help and just like let's take a look at what the options we've got here. So we've got a Docker pull. So we can go ahead and pull an image. So that's what we're going to do. We're going to do a Docker pull Ruparel dash flask OID mag tag, because I believe that's what I called it. Yep. Oh, OID parser. I'm going to copy this. I'm going to cheat. Copy paste. So I can do that. And then I can specifically pull the ARM v7 build because that's the version that will, that's a push. That's not what I want. I want a pull. There we go. So we've pulled that version that we just went ahead and we compiled on my MacBook. It's now being pulled to my Raspberry Pi. Um, my Raspberry Pi is actually sitting behind my desk. It's hooked up to a thermal printer, so I can't move it super easily to show you that it's there. But yeah, so this is going to pull, and then all we need to do to run it is go ahead and do a Docker run. Um, this will take just a little bit. It's going to extract the image. There we go. Almost done. And there we go. So we've downloaded the newest version of this image and we can do a Docker run. And so let's see what I've got in my history. So I've got a Docker container start, container S. So let's do this command. So I've got a Docker run, and I'm going to run this in detached mode. So what that means is, so when I do a Docker run, I'm going to attach to the whatever the container is doing. So whenever we have outputs, we'll be able to see them. The downside to that is when I go ahead and Control C and close out of that container, it's going to shut the container down. So by using this dash D option, we're going to make it so the container will spin up. It'll give us an ID, and then it'll just be running in the background. It'll create a background process to run this container indefinitely until it either crashes or I stop it. I'm going to use the dash P option, which will let it know that, hey, I want port 5000 on the local Mac or on the local Raspberry Pi to map to port 5000 of the container. And then I'm going to tell it the name. So I want you to name this container CFE, and I want you to use this Flask image that we just put together, and I want you to use the ARM v7 version of it. So it's going to go ahead and give us an ID. So now we know it's running, and I can do a Docker PS to look at what's going on. So we've got Docker PS. And now, with any luck, if I reset this thing, so I'm going to go ahead and hit the button on it. You can see it's errored out because the server was down. So I'm going to reset it. And while it thinks, we can actually go ahead and take a look in my internet browser to double check that it's up. Something super cool that I learned in this project is that Raspberry Pis on your local network, actually, as long as you don't change the names or turn these settings off, they actually just map automatically to Raspberry Pi.local, which is so useful because then I don't have to manually specify the IP address. So I can hit Raspberry Pi.local slash 5000 and confirm, yep, it's running. And then if we take a look at the mag tag, we can see that the thing refreshed successfully, which is great. So this way, I can leave this running in my background. I'm able to manage the code over on my MacBook. I can write it. I can do whatever changes I need to on my MacBook, and then I can build it in a way that'll run on the Raspberry Pi, pull it on my Raspberry Pi, and just kind of let it go and have it living on the background um, in my network somewhere, which is super useful. I'm super happy with it. As well. So, if y'all have any questions, I would be delighted to hear them. Otherwise, I think we could maybe share some resources for folks that are looking for different levels of content. I see the chats as well that some folks are looking for some more beginner content or just general refreshers. And I totally hear you, and I want to make sure that I don't leave y'all um, there. So my favorite resources for getting started are actually our language specific guides. And hopefully a lot of this ends up being kind of familiar. So I'm a Python dev, so I really like using the Python language specific guides over on the documentation. There's Node.js ones, there's Java ones, there's Go ones. So whatever kind of version is most useful or language is most useful to you as well, I think these are great. And then, we can get into deeper levels, like if you want to do CI/CD or one of the things that I didn't show, which I think is really useful, is this thing called bind amounts, which is where I can build an image, and when I run that image, when I change my Python code, the image isn't going to update until I rebuild it. But using bind mounts, I'll be able to have it point to my original code, and as I change code, the image will be able to reflect those code changes, and so it'll make local development really, really simple as well. And so that's something that you can learn in the documentation as well, but I'm not going to go into it today. Also, if you're curious about the repository, I've got that up on GitHub. It's just shy/docker magtag oid for the Flask code, and then I also have the code that's running on the magtag right here. If you own one of these, you can go ahead and just copy paste the entire folder into the magtag, and in theory, it should just work. Assuming you're matching the same firmware as what I wrote it for, it'll work. And you can see it's hitting the Raspberry Pi server, and it's pulling an ISO format. So the Flash server itself is taking that 32 megabyte file and um, just only giving us the specific details for the requested ISO. So if I do uh, an ISO data, and if I look at just the world, rather than having that huge 32 megabyte file, my Raspberry Pi is going to hit that 32 megabyte file, grab just what's being requested, and then turn it into a JSON format that the MagTag can eat and and take advantage of and use without being overwhelmed by the file format. So uh, let me go ahead and I'm going to go ahead and just wrap things up with I have a little question slide that has some links as well. if y'all are looking for links um, that are useful. So if you want a shirt or swag or anything like that, you can grab that. But otherwise, I am going to take a look at the chat in StreamYard really quickly and take a look at the chat. Oh, so we got a question from JJ Thornton. Hi, Shy. Outside of the Docker docs, are there any other resources that you recommend? Yeah, I do have one that I really like personally. So one of our community champions, one of our community captains, Brett Fisher, does a lot of really, really excellent technical resources. He has a bunch of really lovely courses that he's put together about using Docker on Udemy. Um, if your work gives you paid educational materials or anything like that, I think this is a great use to use like an educational benefit on. So let's see. We have a Docker mastery. Yeah, so we got his course, and this goes on sale fairly often as well. And it's really great. It's about like 20 hours of video content, and he goes from the very bare beginning all the way up to using things like Kubernetes and Swarm and some of our way more advanced features that I don't think I can go into in a in a 1 hour meetup. And so if you're looking for 20 hours of content, really recommend Brett Fisher's stuff. I think it's really great. Um, and yeah, so let me take a look. Are there any other questions? Jerry says they love the ESP32 boards, so this example really works. I'm really glad to hear that. I'm a big fan of them too. I love doing IoT stuff. I think it's a lot of fun as well. And I don't
We
think I'm
also had
seeing
a
anything.
question
Oh, go
from
for it.
in the Ask a Question module from Alexis. He
Yeah.
asked, for IoT, what Raspberry Pi model do you recommend?
If you can get your hands on the latest one, get the latest one, but they're pretty hard to find. I think the chip shortage has hit
Mm,
them fairly hard. I think just any of the 4 or the 3 models will get you far enough. I really want to mess around with the 4 because it lets you do 64-bit architecture, which I think is a lot of fun and I want to play with, but I haven't been able to get a handle on it or a hand on one of them myself yet. Um, your mileage varies, I think, on whatever you can access. The only one I would hesitate to recommend to a total beginner is the Raspberry Pi Zero, which is going to be like a version that doesn't come with GPIO pins, and so you're going to have to do soldering and stuff to get it powered up. And that one's really great for like hiding inside like LED displays or things like that. I I really enjoy it, but in my head, that's like a very specific use case. If you just want a general thing to like um, highly recommend the Raspberry Pi kind of standard model. Oh,
okay, cool. Um, we also had a question from Dan.
yeah,
It says, a
yeah.
lot of my team issue has issues with Docker on M1 Max. Are there any tools or resources for this?
Yeah, so we're actually still working on making the M1 support more robust. And so my recommendation is go ahead and log support tickets with us to let us know what the issues that you're having are so we can make sure to prioritize them and get them resolved. But we are aware that like M1 support is still coming. We are actually talking to the Apple team fairly regularly as well. And I know we actually just implemented a new, let me pull this up in Docker Desktop, a new setting that makes Docker a lot faster. Let me see if I can find it. I think it's an experimental. Yeah, so we've enabled this new file sharing system, and this is something that we were able to do because they added a patch to. I need to actually turn this back on. I'll do this after the talk. Um, they added a couple internal like APIs that we were able to take advantage of on an operating system level. So we definitely hear that M1 support isn't where it needs to be, and we're definitely still working on improving it. So make sure to file those tickets and support things so we can and bug reports so we can make sure that we're able to address them and resolve them and they're brought to our attention. But I don't have any specific resources on like resolving M1 issues beyond letting us know what bugs you've got so we can make sure that we resolve them. We want it to be a seamless experience, on all machines, whether it's Linux or Windows or either version of like Apple hardware.
Um, okay, sounds good. And Oscar asks, can you show us a little bit more of Docker Hub to run
Yeah.
projects, etc.?
Yeah, totally. So I really like DockerHub. It's kind of in my head, it kind of works a little similar to GitHub in that, I can push my images up and I can share these URLs with my friends, and they can download those images. Rather than getting source code, though, I'm getting generated containers. So I can push images up and you can pull them down. There's also a lot of really great stuff in DockerHub itself. So we can go to the Explorer and we can see we have a bunch of different base images. And we also have stuff like pre-running programs. So like if you want to run Postgres, for example, rather than having to install Postgres, you can just do a Docker run Postgres, and it'll just kind of get started on your hardware. So here we've got Docker run, naming the container some Postgres, setting the environment so the Postgres default password is going to be whatever you tell it, and then it'll just go ahead and run, and you can just connect to it. I don't know if I have any Postgres stuff installed on this machine, so we can maybe just connect. Oh, cool! I have Postico, so let's go ahead and try it, and let's see what happens. We're gonna do it live, so I have no idea how this is gonna work, but we will find out. So let me get off my Raspberry Pi because that'll kill it. So we can do a Docker run, Postgres. We'll set it detached, and we'll also set the port to. Well, let's leave the port alone. I'll just use the. I'm hoping the default one will get picked up by Postico. Um, yeah, so this is a really useful thing you can use Docker for is find those programs that you need to run locally, and rather than installing them, you can just run them in a container. And most of these are maintained officially or by verified publishers on the Docker Hub, and so you can just get a version running really quickly as well. So it looks like it's done and it's running. It's I've got my ID of where it's running, so you can pull up Docker Desktop and um, see that it's running here, and we can go ahead and add a new. Ooh, go ahead and let me double check that I don't have any real passwords in here. I'm going to go ahead and set the password to whatever we set here, which was my secret password. And with any luck, when I connect, this will just work. So I have some connection issues. Is it running on port 5432? So check that. I can do an inspect. And see where it's running. This is running on 5432. Oh, but it's not bound. Okay, let me go ahead and actually bind it. So I'll stop this and I'll go back to my Postgres image, run. I'll make sure to bind it to the setting. Um, leave it blank so it'll give me something generic. Looks like it exited. Oh, because I didn't give it an environment variable. So let me do that actually from the command line again. So -d, -p, 5432, 5432. Name it to something else. Postgres 2. Go. So it's running. And now when I connect again, it should hopefully work this time. Yeah, there we go. So I'm connected to this Postgres database. I had Postgres running in like a couple seconds. And that's something that I think Hub makes really easily. There's a bunch of different stuff up there. You can just get it running on your machine really efficiently and really fast. So, I have a Postgres server running on my machine. I can hit that port and start connecting to it. One of the things I could do is I could also attach like a volume. So rather than when I bring this down and bring it back up, it forgetting everything that's in there, we can give it persistent storage. So it'll actually store whatever changes I make to the Postgres data dynamically, which I think is really, indefinitely. So as I restart and restop this container, it'll maintain my data. And if I mess something up, I can delete that volume and recreate it, or I can back it up somewhere using Time Machine or something, can roll back fairly quickly, which is really useful. And there's a bunch of different stuff on Hub. I know we've got like Plex up here. If anyone runs media servers, you can download Plex, and there's a bunch of different community options that various people have made, and then we have the official stuff as well. That's generally being maintained by the folks that are building the software itself. So like the Mongo one is it looks like we're maintaining the Mongo one, but there's all sorts of different ones across within like the Docker Hub ecosystem. Hopefully that shares kind of some more of the cool stuff that you can do with it and why I like it as well.
Yeah, that's really cool. And I mean, one of the things we talked about, like just obviously deploying to a Raspberry Pi, but I think one of the powerful things that you can do with Docker is really share your development environments,
Mhm.
whereby
Oh
it
yeah.
used to be really complex to, like, okay, you're coming on board, we need to onboard you, get you set up. It's
Yeah.
like spend a full day at least, maybe more, setting up your local development environment.
Yep.
Whereas, like, in this case, you can just, like, okay, everything's in this container
Yep.
and you just work off that,
Yep.
right?
Exactly. Yeah. And you don't have to worry that things aren't going to work on different machines, um,
Right.
regardless of what
Exactly.
you pick.
Exactly. Alexis asks, is the next version of Docker Desktop, will we have Docker extension? We'll have Docker
Yeah.
extensions. Can you say more about
Yeah.
that?
Totally. So I'm super excited for this. It's actually going to be releasing at DockerCon, which is I want to say 11 days away. Um, as well. So we're doing a DockerCon event, and we'll be launching our extensions. So extensions are kind of letting you add more things to Docker Desktop. I have them turned off while I'm publicly demoing, but I've got access to them and they're really cool. So with Docker Desktop, we have the standard stuff, but you'll also be able to add kind of third-party tools here. So like Sneak, that scanning software I used will be right here. Or if you use Circle CI and Circle CI builds an extension, you'll be able to see click into it and get all that information from inside Docker Desktop. We're shipping some default stuff as well, like better logging. We have an extension that has logging that's way more detailed and actually a little overkill unless you're really into logs. We have an extension that we're doing for image management and dangling stuff that'll take care of it. But really, it's for letting folks uh, outside of Docker build things and have them work inside Docker desktops, which I think is going to be really exciting. We have Doom running in Docker Desktop as well. I don't know if we're allowed to ship that, but we did manage to make that happen for folks that are excited
It's really important.
about that. Yeah, we did get Doom. I think that was probably the first extension they built. And also, we're going to be adding Linux support formally. So believe Linux support right now is in beta still, but it'll be hitting general access as well at DockerCon too. So all those will be coming out in like 2 weeks. So keep an eye out. I'm really excited about them, and I'm really excited to actually get to build tutorials and stuff on them because I think it'll be a lot of fun, and be a really
Awesome.
great way to make Docker more useful.
Awesome. And just Antonio would like your slide deck.
Yeah,
Can you
I'll
share it
probably
out?
pull this up, throw it on my GitHub at some point. I'm still like working on these slides. I'm not like at a point with them where I'm like happy with them. So let me run this talk a couple more times and make more changes. But generally, I keep all my talks up on my GitHub at just shy/talk. So you can see I've got a bunch of stuff up here. So this will be up here at some point, whenever I'm happy with it,
Okay.
as well. But you can get a lot of the same content on the Docker docs and in some of those resources as well. But my stuff will be up eventually in this repo.
Okay. Sounds good.